The data is a variable declaration. There are variable name and data type. In number with 40, which is multiply of 10 and 4, because in MIPS language we have to declare the size of number. The size of one integer is equal to 4 bits. We use space as data type and provide some space for the numbers. To print the string in console, we use ASCII as data type and put the string within the quotient braces after the data type, as the value of data type float is the value that we are going to use later. We move to test part where we do all the logic and calculation. In main function, at start we hold 0 value at r, which is called add immediate and similar to add instruction, except that the last argument is a number which 40 instead of register. This line at I $T0 $0 means $T0 equal to $0 plus 40. 40 will be stored in $T0. Forward the line have same meaning. Then we have to prompt the user what they must do. LI is called the load immediate, where therefore system code for the prompt user, and we send it to register. $A0 is operating system. Same as previous, we load the next line, variable which hold value the \n, or in C++ programming language we call as call ENDL, that is escape character to go to the next line. BEQ stands for branch equal. It will compare the first register to second register that came after the command. If it's true, it will go to the address that defines both registers. These lines mean if the $T1 is equal to $T0, at the same time $T0 is currently holding the value of 40, then it will go to continue address. Next part is count how many input have been entered. As you know, $A0 is the function argument register that hold the integer type variables. So this command print the value held by $T9. For this part, to print the column to differentiate between the column counter and the input that will be entered. Next is a chain command in C++ programming language. The file value load into $V0 as a system code to read the integer as stored on temporary buffer. The command chain code is enable operating to read the value and store it into register as $V0. Then we need to move the value into another register to prevent the bad loss. So the value register in $V0 will put into $T2. Next, SW is store words instruction, means we will store the value enter that $T2 who inside numbers at position $T1 where $T1 currently is 0. This is basically to update the number's position. We have been forward with 4 bytes for the integer to go to the next position in numbers. Then we have to jump command, that means the program will go to the address that come after the command. In this case, it will go to the back to the input. The program will loop until it reaches last position of the numbers, where it will exit loop and go to continue.
Assalamualaikum, I am Nur Ailin. At the continue session, the constant value 4 is used as the system call code to print a string. In this case, we want to print string name prompt2. Then, at ADDI that call as add immediate value, we move to the next element of numbers. After that, we load address to both of base address of numbers to register $T1 and register $T3. At this line, ADDI $T2, $T0, 1 means $T2 equals to $T0 plus 1, which in C++ programming language, K equals to I plus 1. 1 will be stored in $T2. Follow the line have same meaning and we set pointer of array into second element. At the inner loop session, we use BGE means branch on greater than equal to compare if register $T2 is greater than equal 10, which in C++ programming language, if K greater equal 10, it will exit to outer loop. We use LW, which we load word numbers of register $T1, which numbers bracket I store into register $S0, and load word numbers of register $T3, which numbers bracket K store into register $S1. Then, BGT as branch on greater than to compares if numbers in register $S0 is greater than numbers in register $S1. If true, it will jump to swap. Then, we have jump increment. At this time, program will swap the numbers by using SW that store words. We put the numbers in register $T3 into register $S0 and put the numbers in register $T1 into $S1. For the increment, ADDI or add immediate to line, ADDI $T2 $T2 1, which makes $T2 equals to $T2 plus 1. 1 means we'll store into $T2. In C++ programming language, it means K equals to K plus 1. Next, we will move to the pointer of array to next element where 4 will store into register $T3. Then, we need to jump back to inner loop. At the outer loop session, we use LW or load word, the numbers in register $T1 store into $S4. Then, we sum the numbers by add value of register $S4 into $S3, whereby the line means $S3 equals to $S3 plus $S4, or in other words, sum equal to sum plus number bracket I in C++. The program will have I equals to I plus 1 in C++ programming language compared to MIPS assembly language. The program will add immediate the value 1 into register $T0, means $T0 equals $T0 plus 1 at line ADDI $T0, $T0 1. Then add immediate 1 into register $T2, which means $T2 equals to $T0 plus 1, or in C++ known as K equals to I plus 1. The ADDI $T1, $T1 4 is used to move the pointer of array to next elements. Then, set the pointer of array to 1 by add immediate 4 into register $T3. The BGE or branch on greater than equal is used to stop the loop if true register $T0 is greater than equal 10. Then, the program will jump to inner loop.
I am Safina. I will go into the X loop session. At this session, we will want to print the message of MST1. So we're using LI or load immediate to perform the operation by system call code 4 and load the address of MST1. Then we load immediate the value of 10 into the register $T2, which is the $T2 is the number dot size, and we load the value of 0 into the $T1, which is the $T1 is the counter I, and we load immediate the value of 0 into the register $T3. At the loop session, we want to know is it that true that I is greater than the number dot size. So we will using BGE. If it true, it will go to the end or otherwise. At here, we load the numbers in the register $T3 into the $A0. After that, the value of 1 is loaded into V0. To print the integer and the system call, code will print the numbers to the console or the screen. Then, it will load immediate the value of 4 into the $sign V0. To print the string, we will load the address of the type variable, which is \t that is escape character, to go to the next space and print to the console or screen. And here we add immediate the value of 1 into the register $t1, which is $t1 equal to $t1 plus 1 in MFPS assembly language, compared to in C++ programming language we know as I equal to I plus 1. D is basically to update the number's position. We have been forward the 4 bytes of the integer to go to the next position of the numbers. Then we will go to the jump command, where it means the program will go to the address that will come after the command. In this case, it will go back to the loop, and the program will loop until it reaches the last position of the numbers, where it will exit the loop and it will go to the end part. Okay, right now we at the end session or end part, where we will print the string message of MSG2, and we by the load immediate of 4 for the system call code for MSG2, and we send to the register $sign A0. Then we perform the system operation. Same as previous, we load the variable next line that holds value the \n that is escape character to the next line. Here, we load the immediate value of 1 into the register $sign V0. We need to move the $signs S3 into the another register, which is $sign A0 that holds the integer data type variables, and print the sum of the numbers. The last one is we need to terminate the program from run and exit. Okay, that's all from us for our MIPS program, and thank you.